how we can divide these large areas into small finite elements. You have to do this for to get accurate results. Okay? You have to divide large slabs into small elements in order to get more accurate results. And we are required to find structures' vibration periods in x and y directions. And after obtaining these vibration periods, you can calculate earthquake loads using equivalent earthquake load analysis. Equivalent load analysis, earthquake load analysis. In Turkish, eşdeğer deprem yöntemi. If you know the vibration period of the structure and if you know the masses and weights of each story, you can find this earthquake lateral loads using some specific method. Okay. And now this is not calculated here, it is given here. First floor we have, in x direction we have this load. These are kilonewtons, of course, kilonewtons. And in y direction we have 46.1 kilonewton. On the second floor, Fx is 56.5 kilonewtons and Fy is 46.6 kilonewtons. Okay. These are the lateral loads applied. These will apply to the diaphragms, okay, or in the center of the structure of the floor level, geometry or actually a mass center or center of mass. You have to apply these lateral loads to the center of mass. And in order to do this, we have to define rigid diaphragms at each floor level. Okay. And we will apply earthquake loads on these diaphragms. And we are also required to consider eccentricity. As I said, you have to apply these loads to the center of mass. Okay, but we cannot be sure that center of mass is always there. Okay? For example, there may be some lie loads which is located on some other part of the lie loads. For example, you can put lie load here and your center of mass changed. Or you can put lie load here, your center of mass changes. Therefore, we cannot be sure always about the location of the center of mass. In order to account this uncertainty of center of mass, we have to consider this eccentricity. Let me explain this first. Arkadaşlar bu kaçıklık, eksantriste demek kaçıklık demek. Şimdi center of mass burası diyoruz, kütle merkezi. Ama mesela dağılmış olabilir, yani yayılı yükün, hareketli yükün nerede olacağını bilemiyoruz. Hareketli yükü tahmin edemeyiz ki. Mesela hareketli yük bu tarafa yoğunlaşmışsa center of mass bu tarafa doğru kayar. Veya bu tarafa yoğunlaşmışsa bu tarafa doğru kayar. Yani bunu bilemeyiz, center of mass nerede gerçekten, yapının gerçek ömründe. O yüzden ne yapıyoruz? Bunun hesaplıyoruz kütle merkezine ve %5 kaçıklık alıyoruz. Bir artı yönde, bir eksi yönde. Bunun sebebi de bu belirsizliği göz önüne almak için. Tamam. Bu eksantriste diye düşünürseniz. Okay. Now I'm going to apply these loads in x direction and in y direction for lateral loads using this eccentricity on diaphragms. Okay. And we will define load combinations. For example, for this first floor, I'm going to apply first floor and second floor. I'm going to apply Fx, and this will be our Ex load combination. Ex load combination will be this Ex, we have here EY, this EX. EX load combination includes FX in first floor and FX in second. EY load combination includes FY in first floor and FY in second. These are EX and EY. And what is this EXP? We have EX. If you consider eccentricity positive 0.0.5, this will be EXP. If you consider eccentricity negative 0.05, in that case it will be EXN. These P and N denotes positive and negative eccentricities. Right? And in Turkish seismic code, you have to also include, for example, with EXP, you have to consider some part of EY also. 30% of EY. You have to consider that. Why we are doing this? Because we don't know the direction of the earthquake. Okay? For example, if you consider EX, this means that you only think that earthquake will apply in X direction, but we cannot be sure about it. Okay? We cannot be sure that earthquake will apply in X direction or in Y direction exactly. Therefore, in order to account this uncertainty again, we have to consider EX together with 30% of EY. And we have to also consider EY together with 30% of EX. You see, EXP plus 0.3 EY, 30%. And if you also consider negative and positive directions, for example, here we have plus, here we have minus. And also we have another positive and negative thing, which is eccentricity. And these are the load combinations. In addition to these, we also consider there are some other load combinations. Here we only consider Dussey plus 1G plus 1Q plus 1E. Okay. This Dussey means vertical. We only consider vertical load combination. 1.4G, 1.6Q. Okay. This is vertical. There's no earthquake load here. And for this case, 1G plus 1Q plus 1E is G plus 1Q plus 1E is another combination. In addition to this, we also must have another combination, which is 0.9G without that load, without line load, plus 1E. This is another load combination you have to consider. But this is not given here for the sake of save time. Okay. We only consider this one and this one. And we also must have another load combination. What is that? In order to find the maximums and minimums of all these combinations. What was that? Last week we also did this. What was that? The load combination which covers all these, which includes all these combinations.
1.4.
For example, I have 17 load combinations. For example, in a beam, in this beam, which load combination will give me the maximum moment in the middle, for example?
GQ is
in order to find, for example, maximum element forces at each member, we have to take another load combination, which is called envelope. Okay. In this envelope combination, this type of combinations, find, for example, for this beam, which load combinations gives maximum span moment for this beam. Which load combinations gives maximum span load for this beam? Or which load combinations gives maximum shear for this column? Okay. These envelope combinations give me the maximum and minimum of all these load combinations for each member, for each frame, for each beam, for each column. Envelope. In Turkish, what is envelope in Turkish? Zarf. Zarf kombinasyonu. Hepsinin içindeki maksimumları ve minimumları alıyor her bir eleman için. Otherwise, how can I find maximums or minimums using these 60 load combinations? I cannot find. It takes too much time to find maximums and minimums of each load combination. Therefore, this envelope load combination gives me the maximum and minimum for each member. Maximum and minimum forces, internal forces, at each member. Okay, is this understood? Envelope is therefore very important. Let me write here. Envelope combination gives me the maximum and minimum. Let me write this in the yeah, güzel anlatacağım. Minimum internal forces. At each internal forces occurred from all load combinations. From all included combinations at each member. Each member. Okay? Envelope combination. Yes?
How to find envelope combination?
Okay, you can define envelope combination using load combination again, from load combination command. Let me show that. Okay, here, for example, let's draw a frame. Define load combinations, add new combination. You see, we are going to add, for example, 1.4G, 1.4Q, etc., or combination names, combination 1. Here, what are combination names? These are combination names, DX1, DX2, DX3, okay? These are combination names. And we are going to include all these combination names and load combination type here, load combination type, we will write envelope. This will define this envelope load combination. Yes?
For 17 formula, we have to memorize it?
Actually, there is nothing to memorize here. For example, 1G, this is okay. 1Q, okay. 1E, for example. 1E can be EX, EY, and EXP, EXN, EYP, EYN. Okay, you have to consider this positive and negative eccentricities plus or minus. Let me put here plus or minus 0.3. For example, if you are taking EX, 0.3 EY. Now this means, let me explain here also. For example, this 1E means EXP, okay, plus or minus. What is plus or minus symbol? Let me find this symbol. Insert symbol. Where is plus minus?
Up.
Up.
Right. Yeah. Up, right. Yeah.
Plus and minus.
Minus.
Okay, this one. Okay. Plus or minus. EXP plus or minus 0.3 EY. Okay. Now how many combinations we have here? Two. EXP plus 0.3 EI, EXP plus minus 0.3 EI. And what else? For example, EXN plus or minus, EXN plus or minus 3 EI. Similarly, EYP plus or minus 3 EI. Okay. And again, EYN, negative X. This P is for positive eccentricity, N is for negative eccentricity. Now how many combinations we have here? 2 here, 2, 4, 6, 8. And we also must have another plus or minus here. Okay, plus or minus, plus or minus, plus or minus, plus or minus. Now how many load combinations? 16.
Yeah.
4 here,
4 here.
4, 16. And one more, we have 1G, 1.4G plus 1.6 here. We have 17. Additionally, you have to you should also consider this one. It is not given here, but let me write this one also. 1G plus, or let me write it here. 1G plus or minus EXP. Similarly, EXI, EYP, EYN. Okay. This is for 1G plus 1E, but 1E is actually there is nothing. 1E means this, okay? There is no need to write this. 1E means this one. Here I'm going to put this 1E, and also I have to put 1E. Therefore, here we have 16 combinations. Here we have 16 combinations, and I have to include these 16 combinations here. 1.1 G plus 1 Q plus 1 E. Okay. This 1 E is this one. Plus, or let's put a semicolon here. 0.9 G plus 1. Now here I have 16, and for this case I have another 16. How many load combinations we have? 32. You have to define all these 32 load combinations in order to consider earthquake effects. Why we are talking about all these different things? And here I forgot something. This should be EX. Because we don't know the direction of earthquake. We don't know where earthquake will hit this structure. In X direction, or in Y direction, or with an inclined direction. Okay. In order to account for all these possibilities, we have to take these load combinations. We have to consider all these load combinations.
So for left side to find density, isn't it? For right side to find what?
For left side,
For the formula, I'm sorry, the formula here. There is two formula.
Yes.
The left side is to find density, isn't it? The right side for what?
what do you mean by left side?
The first one on the left, this formula.
Come here and ask.
For this formula, like you can go up a little.
Uh-huh.
For here, density to find this one, isn't it?
Yes.
And this
No,
one.
no, you say is this one. It is different.
Density is this formula.
Yes, this one.
And this one for what I have to find? This formula.
These are the other load combinations. For example, this is, you have to consider 1G, 1Q, 1E, okay? All loads, vertical loads and lateral loads. And this is reduced. We reduce, sometimes this gives the worst combination, okay? Sometimes this gives us the maximum or minimum values, okay? This is called reduced loads, load case. In that case, Q is omitted and G is reduced by 10%. And earthquake effect is also added here. And therefore, in earthquake codes, like Turkish seismic code or other codes, it is required that consider this load combinations and consider this load combinations. These are given in the codes, standards. Yönetmeliklerde isteniyor bunlar. Okay. Now this means that we have, how many we have here? 16.
32.
We have
This one,
16 combinations. And we also have here